This section looks at expanding the Huawei Enterprise network through the introduction of routing and switching products. So as more and more end stations in the form of host devices, networkable printers, and other similar products are introduced into the local area network, an increase in the density of devices results in a limitation in terms of port interfaces, along with problems of collisions within any shared network topology. Switching has evolved as the means for supporting this growth. VRP is used within Huawei products as a means to configure and operate such managed devices, for which familiarity and hands-on skills must be developed. So upon completion of this section, it is generally expected that trainees will be able to explain the role switches play in the Ethernet networks, describe the difference between collision and broadcast domains, and explain the general operation of VRP within Huawei products. Much of the earlier Ethernet standards were based around the principle of networks that involved a single shared collision domain over which communication required control through mechanisms such as carrier sense multiple access collision detection, or CSMACD. It was not until the late 1980s, early 90s, that Ethernet switches began to be introduced to the Ethernet network. The Ethernet switch enabled the shared collision domain to be broken down into isolated collision domains that ensured through twisted pair mediums such as the 10 base T or 100 base T standards that collisions could be eliminated. Transmission over such media safely allows for bidirectional full duplex transmission over separate wire pairs for isolated transmission and reception of data. The example here shows the individual collision domains that exist and the general simultaneous bidirectional traffic flow that is supported. We have throughout the TCP/IP unit referenced the function of the gateway as a form of boundary between networks and its restriction of broadcast between these IP networks. The range to which such broadcast can be transmitted is referred to as the broadcast domain. Gateway devices such as routers that act as an intermediary between networks represent the edge of a broadcast domain. The example shown here demonstrates the broadcast domain boundaries. The broadcast domain should be understood to encompass all devices that operate solely within the confines of the data link layer and physical layer to which the Ethernet standards belong. As such, in this instance, two broadcast domains exist. Data transmission between the broadcast domains requires that the router, which in this case is shown as RTA, has an active valid connection to both networks. As data is transmitted between broadcast domains, the Ethernet frame is renewed, meaning that the source and destination MAC address information used within one domain is not carried into another broadcast domain. The frame header is always assigned a new source and destination MAC address that is based on the local broadcast domain as the IP packet traverses each broadcast domain. The management of Huawei products, including routing and switching products, is based on the Versatile Routing Platform, or VRP. This is a uniform command line interface, or CLI-based operating system, that is applied across the range of Huawei-based CLI managed products. Familiarity with the navigation and configuration of this operating system is required not only to support the configuration of routing and switching products, but a large number of other products, including wireless products, products that support unified threat management and security services, such as in the case of the Unified Security Gateway products, and the support of unified management products, which rely on other products using VRP in order to retrieve relevant status information of products active in the network. We therefore introduce within this unit details on the navigation and configuration of products to allow for such products to be commissioned for use within the enterprise network. Numerous versions of the Versatile Routing Platform have been developed, for which the architecture over time has become increasingly modular to support a greater efficiency of operation. We find that many products are currently supporting VRP version 5, and some higher performance products are operating using VRP version 8. We represent two common router and switch products here that use VRP to support commissioning and configuration of the product features. The first is the AR2200 router that exists as part of what is known as the ARG3 series of routers. The other is the S5700 switch that comes from the SX7 series of switches. In both cases, VRP is used to implement the product features. Configuration of such devices is commonly supported by establishing a physical connection to the console port interface that we can see in both cases. In the case of the router, it is also possible to access the VRP command line interface via the use of a mini USB interface. The console port is an RJ45 type port interface, the same form of connector as is used for Ethernet-based connections. The interface supports a special form of cable known as a console cable that is capable of carrying commands generated from a terminal to the VRP software. It is common for such console connections to be associated with a serial COM port. However, these forms of port are becoming more and more obsolete with newer devices. Typically, the USB port of the terminal is used to support the older form of connection through a USB to RS-232 serial converter. This allows the USB interface to operate as a COM port on the terminal to allow a connection to the VRP command line to be established. A form of terminal emulation program is often used to establish the connection to the command line interface. This actual emulation software may vary depending on the preference of the user. However, the setup follows the same procedure. The example demonstrates using the hyperterminal emulator found commonly within the Windows operating system. The COM port associated with the connection is selected initially. This is usually COM port 1. However, this may alter if the initial COM port is being used by another process. Once the COM port is selected, the connection parameters are set. We see here that the parameters that should be used for establishing the connection are considered the default parameters for the COM port. Once configured correctly, a connection to the command line interface will be established. And for any device that is being configured for the first time, it is commonplace for a password to be assigned to the device as a security precaution, following which access to the CLI will be achieved. In the case of the mini USB connection, this provides a more up-to-date form of connection that is supported by newer models of terminals without the need for any interface conversion. Connectivity is established between the USB port of the terminal and the mini USB port of the router. If this is the first time for the host terminal to establish a connection via the USB interface, it is likely that drivers need to be installed to support the connection. The drivers are found within the Huawei support web pages, for which the details of download and installation are found within the notes of the training material. The installation requires that an installation wizard be followed, following which a connection can be initiated. The configuration of the terminal for the mini USB connection follows the same process as that found with the RS-232 serial connection. Again, the correct COM port must be selected, following which the default parameters as shown in this example must again be set. The user will ultimately establish a connection through the mini USB in order to begin configuration through the VRP command line interface. So in summary for this section, we have two questions. The first asks, if an Ethernet broadcast occurs, such as in the case of ARP, to which the destination is local, what will the response of the gateway be? Well, broadcasts generated by an end system will be sent to all destinations within the confines of a local network, including to the interface of a router that is operating as a gateway for the local network. Received broadcast frames will be discarded since no frame is capable of being carried from one broadcast domain to another. It should be noted though that in the case of proxy ARP, a new frame is created by the router, therefore the rule is upheld. Which versions of VRP are currently supported by Huawei products? Well, many Huawei products are currently supporting VRP version 5. This is also true for the ARG3 series routers and the SX7 series switches. High-end products such as Huawei's Cloud Engine series switches, which are used in data center networks, rely on VRP version 8.